Hi everyone, welcome to episode 16 of the Exoskeletons and Wearable Robotics podcast. I'm Bobby Marino with the Exoskeleton Report, and our co-host here is Professor Tom Sugar from the Wearable Robotics Association, and we are once again lucky to have Volker Bartenbach, founder CEO of Auxivo, but we will be discussing a completely different topic. Last time it was occupational exoskeletons, and this time it's going to be educational and STEM education exos.
Yeah, thanks, Bobby. Thanks for having me again, and very nice to join you again on a second time on a different topic there.
Yeah, excited to have you here. And before we get started, we do have a couple of new Patreon subscribers. Thank you guys for your support. And as usual, we want to acknowledge our VIP level, which would be, again, Volker Bartenbach right here with us right now. Rita Vasquez Torres, Minmar, and our corporate sponsor levels, Humotech, Auxivo, and HeroWare. Thank you guys for your support. It means the world to us. If your human augmentation company is doing well, please share the love with us so we can continue doing marketing and education. That's my spiel on that.
Just beyond that. No, very glad as also from our side, also Auxivo, happy to support this continuing effort to educate the general public on exoskeletons, which I think might be a nice transition to our today's topic of educational exoskeletons.
Well, let's get started. So I believe that you are currently the only one that has a commercial STEM education exo package on the market that is purely an exoskeleton or an exoskeleton adjacent. And I think that you have quite the story of how you got motivated to do that and what is the problem that you're trying to fix with it.
Yeah, and if you like, I'm very more than happy to share this. I mean, it's kind of also how we met for the very first time at Vericon 2017, where we first publicly presented this project back then on stage. And yeah, I think a lot has happened since then. But I think, yes, at the very beginning, it was a kind of a very straightforward story how we got started into this. And as you know, my background is in exoskeleton research. So I did a PhD at ETH working on exoskeletons. And yeah, the story of this educational exoskeleton is certainly linked to my activity there. And so how the idea was born to develop basically an educational exoskeleton kit as a tool for students specifically to learn more, have easy access to exoskeleton technology, was that back in, I think, 2014, 15 or something like that, I think even a little bit earlier, that at ETH, you remember, they started planning to host a cyberforum. So this large event, which was aiming for people with disabilities, being supported by all kinds of assistive devices, amongst others, users with paraplegia using gait exoskeletons to race against each other. So that was their idea. And this was initiated by Professor Robert, who was also my PhD supervisor at the time. So we all in the lab, in one way or the other, were involved in the preparation of this. And because, I mean, back then in, again, 2013, 14, there were not many gait exoskeletons out there that could have potentially participated in this event. And therefore, also a significant amount of universities started basically building gait exoskeletons to participate here, often in the context of student projects. And this was also how I got involved in this project, because ETH also hosted gait exoskeleton project as a student project. So they were looking to recruit a group of 10 students to build a gait exoskeleton from scratch over the course of 2 years, and then to eventually participate in the cyberforum. And I was, as a PhD student back then, I was one of the project supervisors. So there were a couple of supervisors, and I was one of them to help the students who were typically still in their bachelor or master studies to implement and realize this project. And one very interesting experience back then was that there was a lot. So when this project was posted as a student project, there was a lot of interest. So I think we had like 10 spots open, and we had, I think, significantly more than 100 students applying to this project. So the interest was really huge to do this kind of project, to learn about this kind of technology. And then also when supervising the students who are actually building the exoskeleton, it was also clear it was just interesting, building an exoskeleton as an engineering student, as a design student, but also as a health science student, has a high level of appeal. It's very interesting, and I can follow this. I mean, I was a student once. I was fascinated by robotics, and I got fascinated by exoskeleton robotics in this regard, and it was very clear that so many students there were interested and would like to learn more about the technology. But we also saw that the opportunities as a student to get involved were very limited, actually. So, there was this kind of project, but besides that, you might be able to visit a couple of classes on the subject, maybe specialized courses on the subject, but there was nothing like educational hardware out there, where you could actually, get your hands a little bit dirty and build something really. The thought that was clear back then, where we said, okay, this is something we could actually change, because, I mean, especially in exoskeletons, it's so important that you work with hardware. You need to feel it, you need to experience it to kind of really understand, how a actuator can support you, how a control system can influence how the exoskeleton supports you, and so on and so forth. And to really understand it, you really should build it, put it on, and just experience and feel it. And that was something that basically the idea was born. Okay, I mean, we could actually try to make this accessible to more students. And the idea was also quite simple. It was basically building an exoskeleton robotics kit. So robotics kits are out there. I think you can buy them from Lego, like Mindstorm kits. You can buy them from a whole lot of robotic kit suppliers. But for exoskeleton back then, there was simply nothing out there. So for wearable robotics, there was nothing really out there. And this is how we then started to develop this. I think I don't know for how you did it, but on the very first day, I think we posted something online. You found it, and you wrote me back then and said, featured it on the exoskeleton report. So that was actually kind of a very nice boost to see this, that it was picked up instantly, and to, get a little bit of attention from this side. And yeah, and then we took it from there. So I finished my PhD in end of 2016. And then afterwards, I simply, it was, I worked a little bit on the side doing the PhD, but of course it did not progress so much. But after finishing the PhD, I just said, okay, before I now get a job, I want to finish this. So I want to finish this, I want to bring it out there. And then for the first year there, we had this, you mentioned to us, or you encouraged that we could participate in this innovation competition from Vericon. So this was then one kind of major milestone, to go there to present it actually on stage. And then we launched a Kickstarter afterwards to basically finance it, to bring it to the market, which was also successful, which was also a very nice experience. And then eventually we launched this very first education exoskeleton kit, I think in late 2027. There was a lot of course, activities involved. We needed to incorporate a company to be allowed to be commercially active, and so on and so forth. But then we launched it in 2027. And then it has been on the market for, I think it was on the market for around 2 years in the initial version. And then once we incorporated Auxivo at a later stage, we then decided, yeah, let's continue this at Auxivo. I think it's well in line with what we want to do here, to make exoskeletons more accessible. So, and then over time, we actually further developed it at Auxivo. And today it is actually available in 3 different versions. So from a free to download maker edition, where you need to 3D print everything yourself, to like a medium edition, that is more aiming for maybe students, but also high school and college courses. And then we have now a more advanced version that is, we call the EduExo Pro, which is more aiming to higher education, but also for research labs, to provide them with relatively affordable exoskeleton hardware for any kind of research and experiments that they might want to do. Yeah, and that is kind of in a nutshell how this came to be.
So a few comments on my end. So this really goes to show how humble Volker is, because he didn't just go to the Innovation Challenge at Wearable, but he also won the Judges and the Audience Award. So it was a clean sweep there. And I think for the listeners and for everyone to put in perspective, absolutely right now you can get an Arduino kit with an Arduino board and get some servo motors, but you're missing the hardware and how to get started on where to put the attachment points and how to do the controls. And in the past, obviously, the Lego Mindstorm sets existed, but that was $300 per set. You could link up to 4 controllers, which I did. I did a powered Lego Mindstorm hip knee exoskeleton, but you get about 1.5 Newton meters of torque per joint. So it still gives you an idea of control, timing, comfort, You could actually put it on long term, see how your joints and body feel after that. But it's that intersection between having the hardware, having the software, having the control. And you also have a booklet that comes with it, which is like a mini textbook, I believe, with all of these kits, Volker.
Exactly, yeah, that was the idea. So I think it was always aiming that we, of course, still the theory, the background theory, the understanding is still important. So equally, I would say important than actually experiencing it yourself. It's always the combination about reading the theory, building it yourself, experience it yourself. So yes, absolutely. So all three versions have a booklet with it. So it becomes a little bit bigger and thicker, the more advanced the version is, but also the light, the Maker Edition, what we call, which is the free version that you can download yourself. It also has a PDF booklet, so covering like a little bit of an introduction, like a brief overview of history, and then a couple of different topics, from starting biomechanics, anatomy, so the basics, right? You need to understand the human first before you can build a machine to support a human, so basic anatomy, the mechanics, biomechanics, then of course, all the engineering disciplines, basically, from mechanical design to electronics to software development, control system development is a huge chunk of it. Also into, let's say, more exoskeleton specific topics. We have one chapter in there, which is about EMG control. So where you have a muscle activity sensor that you actually put on your body, and then you can use it to measure muscle activity and use this information then to control the movement of the exoskeleton to support the human user when they actually need it. So that's kind of these topics that are, of course, specific to exoskeletons compared to normal robotics kits. And I think these are also the topics that are honestly the most appealing to most of the students. We have also one chapter in there on gaming, actually. So as you know, in especially in medical exoskeletons, like serious gaming is actually not an unimportant topic. So that during training, during rehabilitation, you actually use your exoskeleton and interact with a virtual game as a motivational tool, but also as a performance measurement tool. And of course, on a smaller scale, we replicate this in this educational exoskeleton. So we have a chapter on game design using the Unity 3D game engine. And then you basically learn how to build a simple game, how to connect the game to your exoskeleton, and then how you can use the exoskeleton movements and motions to control the activities in the game. And these are, of course, all these topics broken down, also a little bit simplified to make it easy and accessible. So, for example, if you measure sensor signals, the filtering is basic, but all the elements are there. So we really want to cover all the topics that are so important to exoskeleton development and use, that you get a broad understanding about the wide range of skills that you can use to develop exoskeletons. And yet the booklet is actually, for the Pro version, I think the booklet is almost 200 pages. So it became quite a textbook. And it's always a little bit, so the booklet means basically every chapter starts with a theoretical part explaining what needs to be done. And then you have a tutorial section, which basically then shows you how you can implement it with the hardware. And I mean, the hardware, I think I did not actually mention this, is a kit, right? So you don't buy an exoskeleton, you buy a box full of parts. And you build the exoskeleton yourself with all the steps involved. So you assemble the parts, you solder some of the electronics, you of course program the Arduino microcontroller yourself. So step by step, you build the exoskeleton, and then you implement increasingly advanced functionality and control systems into this. And this step-by-step approach that guides you through all the different disciplines, we aim to really give students, high school, college, university level, a good overview, a good understanding about how exoskeletons are actually being built and developed.
And the free version is on the Auxivo.com website.
Exactly, yes.
Yeah.
That can just be downloaded directly on the EduExo website. Yeah, this is rather popular these days. So I think we have by now a couple thousand downloads on our own website. And I guess since it's just a PDF version, I guess it has a natural way of spreading that we might not be able to track.
Yeah, no, indeed.
Yeah, it looks really powerful in the sense of if you're a new, robotics student or someone to be new in this area, I actually just downloaded it and I was looking at it while you were speaking, and it goes into the anatomy, then mechanical design, electronics, software, basic controls, advanced controls. But I really like this idea of like adding in virtual reality and video gaming as well, because maybe that's some of the connections that students can do for the future, like have exoskeletons, with gaming, or exoskeletons with AR, right? So maybe you wear an AR system in the future, and then the exoskeleton helps you to, complete a mechanical task or something like that. So yeah, it's really, really impressive. Could you like share any like kind of really nice wins? Like, I don't know, I'm thinking of like a university in Europe downloaded the device, used it for, let's say, a first year graduate class. Do you think, is that where it's going? Or do you think people even use it in the first year, or sorry, like a junior, senior year of undergraduate class?
Yeah, we have seen a couple of nice stories in this regard. So certainly the Maker Edition we have seen also on social media popping up now and then. And I mean, this is always a win if you see someone sharing some pictures having built it. Typically much more colorful than we did originally. So, modified and added items there. So this pops up occasionally so that you see someone sharing on Instagram or somewhere like that, that they built it actually and they like it. So they tag us and then we see it. And of course, you always say at least a thumbs up. That's very nice to see all the time. So the Maker Edition, so the digital version, I mean, we have mostly seen now with private users. So hobbyist students, I would assume. So with people who have a 3D printer at home, or people who are naturally inclined to build electronics, build robotics project at home. I think this is typically the audience. It has been used in a couple of student classes. So I think last time I see, for example, Eric Buba from Marymount University, I think he has been integrated it somehow in his educational topic. But most of the universities actually use more boxed versions. So the what we call now the light version or the pro version. And apparently there's not about, I would say, what we have heard so far is more about the additional time saving that you have. So if you basically get it all in a box, then the price, of course, is still relevant, but it saves you so much additional time. It's just that you do not need to buy everything yourself or print it yourself, that it's the additional time saving. And here we have a couple of nice examples. For example, Urs, from Stuttgart. He has been using it in his, I think, biomechatronics class. He has, I don't know how many actually, but he used a couple of them. At ETH, a couple of labs actually are using it. In France, a university, that was a nice project. It was I think it was a first year PhD student. She bought one to basically have a quick platform to test controls ideas, I think, basically as a starting point for the PhD. So to be equipped with hardware very quickly, and based on these initial experiments, then she decided to develop a little bit more advanced platform herself. But as a starting point, that was a nice illustration how we can basically, lower the threshold of accessing exoskeleton hardware for learning or research. And that was exactly our goal. So this is actually nice to see, to really make the hardware more accessible, because we see it as crucial for the learning process. Yeah, so no, there are more and more examples there. I think we're also preparing at the moment a new website where we can share a couple of these examples just to give more ideas. And the idea was also at some point that we can share a couple of class examples and course examples to provide this information, how it has been used in classrooms. And yeah, actually the pro version was developed based on inquiries from academia, because the light version, I would say, it's nice. But it's a simple device. It's just the elbow exoskeleton. It has a comparatively weak motor, so it's more about soft guidance than real support. And from academia, so from higher education, universities, colleges, this was where the interest in a pro version came from, where they just said it's nice, but they would actually like a little bit more impressive version as well, because I mean, learning about something is, if it's exciting, if it's interesting, is of course helpful. And the idea was, could we have something that might look even more technical, that could demonstrate more advanced techniques, and it might also be a little bit more powerful, just to, have more freedom in what you want to implement with it. And this is how we implemented or decided then to design the pro version. And yeah, this has now also been iterated and improved in a second version not that long ago, actually, also to just, acknowledge the needs of academia, how they want to use it, that, sometimes then technical robustness is more important than all the do-it-yourself aspects, because you want to use it in courses. And I mean, you are in academia, right? You said before you're coming from teaching, and I did teaching as a PhD student, as a TA. It's always time consuming. And I mean, if you have something that you can simply use, that you know it works, that you know you can implement your course curriculum in there. And this is our idea how we can support educators in integrating exoskeletons into the classrooms.
I think it's extremely important because we're a project-based campus. We're at ASU Polytechnic. We want to see people actually make things and put things out there in society. And it's hard. I mean, I always tell people hardware is hard, and that's why not as many people do it. And because the wiring breaks, like people don't realize, like, to me, like, connectors are so important. Like, people want to just hand solder or do something, just get it working. But like connectors, like if you want an elbow to work for 20 cycles, that's A. But if you actually want an elbow to do, let's say, 100 cycles for 3 days, or no, sorry, not 3 days, 30 days, now you're up in there, and it's a lot more difficult. So I do see the real need of getting to people to actually build a control. Like, to me, you'll never learn, even just something simple, you'll never learn a PID controller until you actually implement it and try it and get that, try out those PID gains and get it on a person and use it. And also, I think we've always said this too, which is why we were having those WearCon conferences, is that exoskeleton, you have to feel it, you have to wear it, you have to try it. It's not something that you can look at in a video and decide, oh, I think it's okay or not okay. It's got to be something you put on and wear. And so that's why I think this type of work is exciting. So thank you.
Well, thank you very much. And I think this was the idea, right? I think you are very actively pushing this field. Bobby is also very actively promoting this field, and I think this was also for us. It's a win-win, right? I mean, we can make it accessible to new people. We make it also understandable and make it more graspable to new people. I mean, we always find. I mean, I think you mentioned it last time. We always fight this science fiction problem, right? That if you talk about exoskeletons, there's this association with science fiction and the future, and this is nothing for today. This is maybe something that is coming tomorrow. But for us, this is if you build this kind of exoskeleton, then it's just reality. Then it's everything. You realize that everything can be understood. Everything has a reason. Everything can make sense once you have done it. And then we also can, or hope at least, to contribute to making it more normal. That more and more people are just, not only have seen it, have experienced it, as you said, have worn it, and maybe in our case even have built one. And that is clearly our goal as well, to just make it a little bit more normality for more people. And yeah, of course, I mean, also we use it, I mean, to be here at Auxivo, we also use it as an onboarding tool. So every new student basically that joins us, or every new technical team member who joins us can build one. Or for the students who do internships here, student projects, they get one when they leave as a gift. So there's also a little bit of a tool to, to onboard people, to basically make sure they have we know what kind of basics in knowledge they have covered, but also as a nice gift opportunity to basically, spread it a little bit and make sure we can help people, making this a little bit more normal.
And you mentioned the Unity engine when it comes to gamification and virtual reality. But I think you also posted on your website collaboration with a university where they use the Unreal Engine and the EduExo Pro.
Yes, yeah, that was a project that we not that long ago we shared, and we also have a brief project description on our website if someone is interested, with also a very short video. No, this was a very interesting project. So it was a little bit of a test project, also to 10% also simply a fun project, where we had a university. And they had a group of students who basically used 2 of our educational exoskeletons, the larger one, the Pro version, to build these we called it a exoskeleton arcade machine. So there you can actually, it's about, simply playing games, and we want to try to test how much we can use exoskeletons to increase immersion. And this is, Tom, what you mentioned before, right? This could be in the future with augmented reality, but also virtual reality. And there we basically try to put everything together. So we had a stationary test rig where we have the exoskeleton left and right. So you were able to sit down on a chair and enter your arms into an exoskeleton on the left and right side. In front, you had a video screen, or you were able to put on virtual reality glasses. And then we had a video game, yes, programmed in Unreal Engine in this instance. It was also for us just a test, basically, if we could connect the educational exoskeleton with the Unreal Engine to see if this is technically feasible and how it can be done. And no, the students did a great job. It was the University of Applied Science here in Switzerland. And they know that over the course of a semester, it was a team of 3 students first. No, they built the entire setup from scratch using these 2 EduExos. And it was quite interesting. It was quite impressive. So it was, we had the avatar. The avatar itself was basically also wearing a virtual exoskeleton in the game. And so then you were basically able to control the movements of the virtual exoskeleton arms with your real arms. And then you put on, especially with the virtual reality glasses, you put it on and you look left and right, and you see your virtual exoskeletons and you feel them on your body. That was quite interesting. So I'm also quite sure, in the future, there can be much more done into this direction. Either being it for entertainment, so actually for gaming, or maybe also what you mentioned before can be done for remote training, teleoperations or something like that. I mean, there are activities in the field, at least in research at least. So this was our little project to explore this a little bit more. No, it was a great project. It was a lot of fun, and was quite interesting to see what works, what doesn't work. So there's certainly also things to improve. But I think this was also something to simply showcase what can be done with these educational exoskeletons, and to give people a couple of ideas, in what kind of student projects they might want to do with that, or to inspire that.
And I think the very initial proof of concept was playing a Pong game where you are throwing a simulated ball and seeing where it lands based on the exoskeleton input into the game.
Exactly. So it was a team of students. So the first game they implemented was beer pong in a 3-dimensional space. But no, it was nice. So it basically was the exoskeleton was mostly used for tracking. So you basically can project your arm movement into the game. And then you had a button at the end of it that they added. And here, if you then hold the button, you held the ball. And if you let loose of the button, then you threw it away. And then they eventually implemented some basic physics, at least some kind of gravity, so that the ball was on a trajectory and either hit the target or not. Yeah, that was the first game. And then eventually we had a second student project who was then diving more into the game development side. And he was a little bit more, creative, I would say. Also spent, of course, more time on the game development. And that was quite interesting. So he had kind of an exploration game, Avatar inspired, where you run around in a jungle, on a jungle planet, collecting boxes and shooting targets. Yeah, that was quite fun. That was very interesting how it came together.
It is quite interesting. Like, maybe what's coming to my head now is what we need to do is basically get in an EduExo, and then it tracks your movements, and then it'll move a humanoid, right? Because that's everyone wants to get in some of these humanoids too, right? Lately, so.
Yeah, or you can take it one step further, which we tried at one point in time. Was also quite fun. 2 people wearing an exoskeleton, and the one person controlling the other. So it's like you can become a puppet master, and that is a very interesting feeling. So if you're standing in the opposite front and you basically mirror the movements, you have one exoskeleton passively, so it's only recording the movements, and the other one is actively projecting the movements on the other person. That felt interesting.
Yeah, you could assist your parent as they're walking down the street or something, Interesting.
Yeah, so as an input device and as a force feedback haptic output device, I've always wanted when they were just getting started with virtual reality, augmented reality here in Silicon Valley, they had multiple stations by different companies where you could go and try out different games. And I immediately wanted that to be an option. So like when you do the virtual reality archery game, if you can have the exoskeletons apply that force, so you're not necessarily training the back muscles as much, but you have that physical feel of you pulling on the ball string, of you releasing. Or when they had the lightsaber duel, that when the lightsabers strike, you can actually feel that force in your arms and your hands. And if your opponent's actively trying to push down, you actually get to feel that folding in your arms.
I think there are actually a couple of exoskeletons out there. I think also in the context of this project, we looked a little bit more deeper into this. I think there are actually a couple of gaming exoskeletons out there, but so far I think except for the Nintendo Power Glove, like decades ago, I think there are a couple mostly hand exoskeletons. So I think it's more about, recording hand movement and probably rendering haptic feedback to the hand so that you feel grasping objects and so forth. And then I think I saw a couple of at least prototypes of more or less full body exoskeletons that you can basically track leg and movement to really interact and move around in the virtual world. So I think there are a couple of interesting out there. I think so far I have not seen one that is really yet, let's say, widespread is anyhow the wrong word, but a little bit more used. So I think this technology, as you said before, I think the more virtual reality activities might become more normal. Maybe the haptic part of a wearable haptic exoskeleton might follow. So this will be interesting to certainly observe over the next couple of years.
Yeah, and the EduExo Pro being elbow and elbow shoulder devices can be a gateway for people that want to tinker with that, both students and entrepreneurs.
That would be, of course, nice to see. I mean, if in 5 years we see someone who basically has launched a haptic exoskeleton company and they started a journal with an EduExo, I think that would be certainly a very big win.
Indeed. So I have a question for you. We saw in 2024, we had the 3rd edition of the Cybathlon. There was the ASTM Exo Games for first responders, which was students building exoskeletons and actually using them against standards. So it's like the closest thing you can get to field testing. And there was also the Applied Collegiate Exoskeleton Challenge as well up in Canada. Do you think that for teams that are just learning about these exoskeleton competitions, on a time crunch, they can potentially use the EduExo Pro just to have a quick start and be able to enter
these kind of competitions? It very much depends on the competition. I think the EduExos, I mean, they cover kind of the technologies of any kind of normal active exoskeleton, I would say. And so it gives you a good overview. I think it will also inspire ideas of how things are being done. And of course, you see a lot of components, how they are being used. So depending on your prior knowledge level, you will learn about basic components, actuation, mechanical design, 3D printing, electronics, and so on and so forth. So it's a lot of engineering knowledge that you can, of course, apply for your challenge. If then you can use basically an EduExo and modify it for whatever project you want to do. That very much depends on the project, of course. But we have seen, let's say, very interesting applications. So we have seen kind of people using ideas from the exoskeleton to develop very different devices. So for example, a user with a spinal muscle atrophy, so he is becoming progressively paralyzed. He, together with some researchers, used kind of EduExo ideas to develop a support device for his arm. So doesn't look like an exoskeleton anymore, but if you look inside the device, you will see many of the components of the EduExo being used kind of there, right? So the sensor, the angle sensor, the motor, or a similar motor, the control system, and so on. So I think, again, depending on what you want to do, it teaches you a lot of engineering knowledge and a lot of, let's say, control systems, and of course directed towards developing devices to support a human user. We've also seen highly modified EduExos that some people just adjusted to their needs. So basically, you keep the mechanics, you rip out all the electronics, and then you build whatever you like on top of it. So we have seen heavily modified things, and I think it shows that, sometimes for especially student groups or something like that, access to mechanical manufacturing facilities might be limited, or the expenses might be too high. And then you can, of course, then it's quite nice if you can use these kind of platforms as kind of a Lego kit, right? You take it apart, you keep everything you need for your own project, and then you put it back together. And so I certainly have seen examples of that, and I certainly see it's possible. But if you could help a student doing this kind of competition, then really depends on what they want to do. So recently we had a student actually in-house here that we asked to basically build a leg version of the EduExo. So just to try it out, right? To see how this would look like. I mean, it's exoskeleton, you can put it on your leg, and then it might not work out of the box. And he did quite a good job. It was a very short project. So for this kind of a couple of weeks only. So for this kind of time frame, he did really an excellent job actually. But of course, you also saw, you cannot turn an arm exoskeleton very quickly into a leg exoskeleton. So there are limitations of how that can work. So we had actually at the end of the day quite a significant amount of modifications in there. But it certainly can be done. I mean, it's always nice to have a starting point for many of these projects, right? And if you have just a white piece of paper, or you have an exoskeleton that you can put on there for brain, and maybe it's just for brainstorming ideas, and use it, disassemble it, use it for rapid prototyping, and then reassemble it in the context of this kind of Frankenstein exoskeleton. Honestly, this is what we do in development every single day. We have a whole bunch of exoskeletons lying around here, some from testing, some from development. And if we develop something new, we have by now a section in our R&D location over there dedicated to old stuff that we don't need anymore, just for rapid prototyping. So I think in this context, with this kind of background, of course, the EduExo can use in a similar way as a starting point.
Wow. Yeah, this reminds me of the how single joint. For a while they were marketing it as exoskeleton that you can either use the elbow or on the knee, I believe.
Which one? Which one is this?
It Cyberdyne, right?
Yeah, the Cyberdyne house single joint.
Okay. Interesting.
But that was some time ago. I'm not sure if they still market it as a device you can put anywhere. I've seen one more recent one, which is almost like a pulley system, and you decide kind of like where you want it to go. And one end attaches to clothing, while the motor unit has more of a typical belt system.
Okay, interesting. Yeah, honestly, like for the EduExo, we very consciously made the decision to go for the arms, actually, because simply a much weaker motor can kind of demonstrate effects to a much lighter arm much easier. And if you use the same thing on your leg, it might simply be not very impressive, because you need much higher torques there to actually move something around. So for us, the arm was for educational purpose, where we would like to demonstrate exoskeleton support. The arms was much higher. And of course, the other aspect is basically, if you want to use it in a classroom, it's very helpful if the students, don't need to take off their pants to put it on. It's especially with the hip device. If you want to measure EMG or something like that, and you have a leg exoskeleton, then you might need to measure your legs and your hips, which is not very fortunate sometimes in education.
I don't think so. But I was thinking about it when you're talking about, when Bob was talking about pulleys too. Had you ever thought about doing an educational system that has more passive elements? So like, you're famous for some of your exo suits or fabrics or pulleys or things like that. Have you ever thought of adding some extra pieces? Just thoughts.
Yeah. We kind of did that with the EduExo Pro. So with the EduExo Pro, also only one joint is actuated and one joint is actually passive. So the elbow joint is actually passive. And we did this also intentionally to basically demonstrate these different ideas to students, because then you can test both, right? And you can also use the EduExo Pro. And this is actually something that we encourage in the first part of the tutorial. You can also remove the entire elbow section, and you just have the passive elbow joint, and then you can use it as an overhead exoskeleton and do a couple of experiments with it. So that is
Passive shoulder.
Passive shoulder, basically, yes. So just very simple mechanism, so nothing very elaborate, very simple. You need to, it's just a torsional spring. So it is not, let's say, a smart support system that is dynamically adjusted over the range of motion. It's just a spring. The further you move in one direction, the more it pushes you against it. But it's still a possibility to illustrate the effect. And yeah, exactly what you said, just to demonstrate what passive is, what active is, what are the advantages of the one, what are the advantages of the other. That, we want to, there are these different kind of design approaches out there that can be used in exoskeleton, soft, rigid, active, passive, and so on. And we actually addressed this in the EduExo Pro specifically, where we have an entire section about exoskeleton development. Because, as the target audience here, we want to educate about all the different possibilities, so that the engineers that come out of this basically have all this knowledge in their toolbox. And if they then are supposed to develop, for example, a professional exoskeleton, then they can decide, they know the advantages and the disadvantages of the different approaches, and then they can choose the proper technology for the requirements the exoskeleton would have. And this would be the idea, really go through all these different topics. And in the Pro version, actually, we have a section where we also do a couple of experiments in the end. So you can adjust the spring, the torsional spring in your shoulder, and then you use the EMG sensor, so the muscle activity sensor, not for controlling the exoskeleton, but to actually measure the support of the exoskeleton. So you can, you can implement, you can put the spring in there, you can activate it, and then you can lift your arms with and without the exoskeleton, and you can measure if the muscle activity is reduced by using the exoskeleton. And that you can do for the active part or for the passive part, while the active part is, of course, a little bit more challenging there because you need to program the exoskeleton in a way that it provides meaningful support and goes out of the way if you don't want it. So yeah, a whole lot of topics that this is why we ended up with almost 200 pages. It's just exoskeleton technology is so broad, so there are so many aspects to it. But again, I think this is, I mean, maybe closing the circle a little bit. This is why I think it's so fascinating for so many students. So it is why it's so appealing. And I think this is why we also think it has been, I mean, this is now, of course, it's teaching exoskeleton technology, but I think we also have seen it being used outside of the world of exoskeletons, just as a general STEM kit instead, because it covers so many different topics, all the engineering stuff, all the programming topics, but also the anatomy, the biomechanics, and so on. So it's let's say it has an interesting appeal to a wider audience that might go beyond, the people who are already familiar with exoskeletons. And we have seen this that it is not only used in engineering classes, but also in, again, movement sciences classes and so on. So it is a little bit, at least so far, it looks like we go a little bit beyond the realm of exoskeleton, and by doing so, make it more known, basically.
Yeah.
It's wonderful work. Wonderful.
And in full disclosure, I think Dr. Matt Dickinson also has a passive STEM education kit, although I myself could not been able to get my hands on it. But that's also a resource for anyone listening to know about, that it exists. It's there.
It's a quite interesting one. I think I have seen it, right? But Matt is he's also building the Hardiman project, I think, but his educational project can be downloaded, I think, as well.
Yes, but I do not have a link to it from, at least not from the Exoskeleton report. Do you have the link for it by any chance?
Me? I at least I had it once, so I don't know but it was a very interesting project, I think. But does he offer it already now commercially for download publicly?
No, it's not.
It's still
not available. It's still in development. To the best of my understanding, it's still in development. At least the last time I asked him about it. I just want people to know that it exists. It's out there. It's being worked on.
Yeah, I had a chat with him once, I think, about it. It was quite interesting to see. But I think this is very important that we have a little bit of more opportunities to get involved in this regard.
It's just nice to have these resources for kids, because when I got started with the Lego exoskeleton, that was $1,200 just for Hi Hello, and then they discontinued it on top of that. So there's nothing I can do with it. It's not supported. It's discontinued. So these things are expensive to get into.
Yeah, absolutely. I mean, yeah, that was also the idea, I think, also to offer it commercially. I think by doing so, it is more sustainable. So I think, I mean, I've seen it in during the PhD, right? You have a lot of these research prototypes, also a lot of other educational exoskeletons out there that have been developed by universities for the specific course. They're just not accessible for anyone outside of this course, and they are not available. And typically, if the course, is cancelled, or more often the PhD students who actually know how to use them leaves after finishing, then this knowledge is, then you have this cycle where the knowledge is lost again and it's no longer accessible. And I think this was also well thought. Actually commercializing it here is a win-win. Of course, for us, it's let's say a business case, but to be honest, this is more giving to the community than taking, also financially. But it is, of course, a way to make it sustainable. So it's basically financing itself, where you can make sure we can improve it over time if we have feedback, but also simply keep producing them and offering them by having them commercialized, and to avoid it being the knowledge being lost again. Once
as a
faculty
member, I've seen that a bunch of times where projects are really important, then the grants go away. And so then the project becomes less important. The PhD students graduate, and then some of that knowledge goes away. And I think, and I'm hoping that doesn't happen in the exoskeleton community, where like we've built this, we've built that, we built this, and so some of that knowledge starts just to fade away. But let's end on a positive note and say how important this topic is, and how educating people in STEM is extremely important. And how, when I was looking at your website about how, you're focusing on mechanical design, electrical design, controls, VR, gaming, if you think about that, you're putting all of these really interesting topics. I guess there's only one topic maybe you need to add in the future, or some artificial intelligence, right? Get some AI in there, put an AI engine in there, add some chat GPT where you can talk to the Exo and the Exo talks back to you or something like that. And it'd be interesting.
The voice module that you can actually voice control it, yes, that could be then needs to be the next step.
Or do character.ai have a character with exoskeleton on top of the character or something. Anyway, I don't know, just making it up, but extremely important topic. And thank you for educating the community. Thank you for everything you've done. Any other thoughts, Bobby? Or
No, I think that is a great way to end it here. Anything from you that we might have missed?
No, I think we covered it. I think it's also not a complicated topic. It's rather straightforward, right? It's if we want to make it accessible, we need hardware to make it accessible, and we try to offer this hardware in enough versions that we have a good solution for everything from a student to a higher education. And I hope with the current offering that we have, we can provide this, as you said, to the community, but also to especially everyone who would like to start learning about it, so who might not yet be in this community. And I hope we got one step closer to this, and and hope we can continue this over the next couple of years to see where this can go.
Yeah, I think there are definitely some levels of complexity here. I was the president of my high school robotics club, and it was very difficult to have access to the STEM education or robotic kids. It was very difficult for everyone who was interested to actually be able to have hands-on touch point with all aspects of it. So we ended up dividing a few people doing electronics, a few people doing CAD renders, virtual reality, a few people handling the business side. So it was not as immersive as it could have been, because having that access, having it be standardized, like we bought a bunch of hexapods, for example, and already only less than 1/5 of all the members were able to even touch the device, let alone learn something from building it.
Yeah, and I've done some of the first robotics, which is absolutely fantastic. But the first robotics is very, very, very expensive to put together a team. And then you really spend most of your time designing, welding, machining, building, some type of vehicle system. And I think where this gets there is it gets at something that could be used for rehabilitation. It could be used for mobility. It could be used for assistance. It could be used for VR and AR gaming, but it could be something that really helps the person, instead of, like I have this giant mobile robot shooting balls and pushing and shoving and things like that.
Which is controlled by joysticks on top of that, because I've also the US first.
Right. So it's really, some people would claim that it's not robotics because it's more teleoperation, and I don't want to get into that arena, but it's certainly mechatronics. It's certainly design. It's certainly CAD and they certainly program, devices and things like that. But I still think it's a passion of mine. I think it's a passion of everyone on this screen, is to think about mobility and assistance and helping the human condition. And so I think that's why this is so important.
No, absolutely agree with you on that.
Thanks for your time. We're so happy to have you here again for the second time on a completely different topic.
Thank you very much for having me again. It was, as last time, it was quite a pleasure and experience to join you on this podcast.
Pleasure is all ours, and I hope the listeners were able to learn about STEM education exoskeletons. And with that, please support us on Patreon. Check out the weekly newsletter. It's one of our new initiatives. If you want to stay up to date exoskeleton and related technology, take a look at the other podcast episodes. Anything else that I'm missing, Tom? Events calendar. If you want to know about exoskeleton events, take a look at the events calendar on the Exoskeleton report. New devices are being added to the exoskeleton catalog as time permits. We have at least another 20 to update right now as of recording this. And thank you for your time. And we hope that everybody has a wonderful day.
Thank you.
Thank you. Ciao, Bobby. Ciao, Tom.
Ciao.